Hello, Stats 300, and this is Professor Gonzalez, and I'd like to do some homework problems from the assignments out of Alex HW 5.3. And our first question here is asking for us to compute the probability of A and B. Now that looks like that might be fairly straightforward because we do have a formula for that, but let me explain why it's not as straightforward as you might think. And also, if you want more more in-depth lecture on this, I'm going to, well, you could look at the adaptive homework 5.3, where I have more details, and I do a little mini lecture on all this stuff. So let's take a look at the formula sheet, and I'm specifically looking at this probability of A and B. So we're looking at this formula sheet here, and I got the probability of A and B, right? And it's easy enough. That just says to multiply the probability of A times the probability of B. So that's pretty straightforward. And also let's highlight something here. This is specifically for when you have independent events. So that's the catch there, right? And then we also have another formula that appears to be doing the same thing. Now this is called the general multiplication or multiplicative or multiplication rule, where we have the probability of A and B. And so this is for, let's see, so this equals the probability of A times the probability of B given A happened. Okay, and that's our general rule. And this is for when it's not like this. This is for when it's, you can call it dependent, or you can say this rule is used when it's not independent. Right? So this is when it's not independent, we use this. And when the events are independent, it actually makes the formula easier, and you just multiply the probability of A times the probability of B. Okay, so this is why this problem is a little bit complicated, because both these formulas will give us the probability of A and B, and so we don't know which one to use. That's the problem at this point in time, okay? So we have one way to get around that. One way is, there's a couple ways actually. One way is to do, I guess, is to do part C first, and then we'll know, because we're trying to figure that out. But I think they're trying to have us do something else first by using these formulas to try to kind of get this done. So notice what is given to us. We have the probability of A, right? We have the probability of B, and we're also given the probability A or B. So there is a formula that has all three of those pieces, plus it has this piece, probability of A and B. And so if we have a formula that has all those parts and pieces to it, which would be this guy right here, this is called the general addition rule, right? So it's a probability of A or B. So let me write this up here so you can see this. Where are we at here? We've got the probability. Let's see, where can I fit all this? I think I can fit it right here. So if we have the probability of what is our formula? The probability of A or B. How do you find the probability of A or B? Well, it's just going to be the probability of A plus the probability of B minus the probability of A and B. So what we're going to do is we're going to fill in all the pieces that we know, and I'll just use a little color just to start us off. I do know P of A, and I know P of A happens to be 0.2, so P of A is 0.2. And I also know P of B, there it is right there. P of B happens to be 0.7. I don't know P of A plus B, because that's what I'm trying to find, right? That's what I'm trying to find. But I do know, one more, I do know the probability of A or B happens to be 0.8. Probability of A or B happens to be 0.8. So what do we know? We know a lot. The thing we don't know is the thing we're trying to figure out. So this is a variable, just like if you're trying to solve for x, you're trying to solve for this whole piece, probability of A and B, and that'll give us an answer. So the first thing we have to do is we have to simplify this, and we're just using algebra now to simplify, add like terms. This gives us 0.9 minus the probability of A and B, and it equals 0.8. Of course, we subtract 0.9 from both sides. When we do that, that's going to give us a negative 0.1 equals, that of course zeroes out, equals negative probability of A and B. Try to make that B a little nicer. Probability of A and B. So notice they're negated. So we multiply both sides by negative, and you can show that or not, but when you multiply both sides by negative, it just changes those signs, and we get the probability of A and B equals 0.1. So that's the answer. Okay. Next question. It says part 2. Are A and B mutually exclusive? Well, for A and B to be if they were mutually exclusive, then probability of A and B would have to be 0, meaning they do not overlap. But the fact that the probability of A and B equals something, this means that the events A and B are not mutually exclusive. So A and B are not mutually exclusive because there is some overlap. And I believe the pull down menu says the reason why, and you have to choose, and the reason why would be because the probability of A and B doesn't equal 0, and that's what you would choose. Now, if they didn't give me a pull down menu, another thing that would also work, I'll write this in a different color, but another thing that would also work is to say, well, the reason why they are not mutually exclusive because the probability of A and B equals something, right? We found out in the previous problem it equals 0.1. That would also prove that it's not mutually exclusive, okay? So either one would work, but this is in the pull-down menu, so we'll just use that pull-down menu in the ALEKS program. Part C, are A and B independent? Okay, so there's a couple different ways that I could think of right away to check for independence. One way is, let's go down to my formula sheet. And one way to show independence is that mathematically we can say events A and B are independent if knowing whether A occurs does not change the probability of B. But mathematically we can say it this way. The probability of the probability right here, the probability of B, given that A happens, if that is the same as that is equal to just the probability of B, that means that this little a did not change the probability, and so therefore that would prove that A and B are independent. Okay, so if you have B given A and probability of B, and you can see if they're equal or not, and that could tell you if they're independent or not. So I did it that way, and that's a fine way to do it. When I did the pull down menu, they had a different choice, and probably a faster way to do it would be to just take a look at our formulas up here. Let me go back to my color. Let's see, I guess I got to use black. So essentially, if probability of, I'm right here if you can't see where I'm at, the probability of A and B equals the probability of A times the probability of B, that would prove that A and B are independent. On the other hand, if the probability of A, let me write right here, if the probability of A and B does not equal the probability of A times, more of it went away, times the probability of B. So let me say it again. If the probability of A and B does not equal the probability of A times the probability of B, that would prove that A and B are not independent. Okay, I think I'm going to highlight that with something else. Let's highlight that with blue. Okay, so we're going to use that little rule right there. Okay, so let's do that. Let's take a look. Where's my problem? Here we are. So what we need to do is we need to show, we need to take a look at the probability of A and, so let's see, let me write this down right here. Probability of A and B. And we want to kind of compare that question. I'm going to put a little question mark. Does that equal the probability of A times the probability of B? Once again, just to reiterate, if they are equal, we know that they're going to be independent. If they're not equal, we know they're going to be not independent. Okay, let's see what happens. So, do we know what the probability of A and B are? Yeah, we do. Probability of A and B, no, wait, that's not it right there. There it is right there. The very first problem, the probability of A and B is 0.1. And do we know what the probability of A is? Yeah, it was given right here. I'll do that. It was given and I made it red. It was right here at 0.2. And do we know what the probability of B is? Yeah, it was given and I highlighted it green right here. That was 0.7. And so if you multiply those two, we get 0.7. We get 0.2 times 0.7. My dog is snoring. I had to wake her up. 0.2 times 0.7. We multiply that. And what do we get? We get 0.14. And on the left side, we've got 0.1. So these two sides do not equal each other. So remember what we said. When they do not equal each other, that's going to be not independent. So we can do that now. So we're going to say events A and B are not independent. Oh, it's already wrote for us. Not independent. And then choose a reason why, and you would just simply choose that they're not independent because the probability of A times the probability of B is not equal to the probability, I wrote it backwards, I guess, the probability of A and B. I mean, it doesn't matter that it's backwards, but the formula sheet had it in reverse order. Stuff on the right was on the left and vice versa. But that would prove it for us, okay? Let's take a look. And basically, question number 2 is the same type of problem. Again, I just wanted you to see me do it, and then I want you to try it, see if you could do it now. And you can pause the video and do it, but you know how that goes. So I'm going to dive into it right now. And so the first question, once again, we have to remember that the probability of A or B equals the probability of A plus the probability of B minus that overlap probability of A and B. So we go ahead and start pulling our information. Probability of A is 0.2. I wish they used some numbers that were a little more creative. Probability of B is 0.7, sounding kind of familiar. Hopefully something is different. And the probability of A or B is 0.9. Okay, good. So it's slightly different than the last problem. Ever so slightly. So we've got an equation plus and then minus our probability of A and B. And of course, we just have to solve for the variable probability of A and B. This is going to give us 0.9. And of course, we subtract 0.9 off of both sides, which gives us 0 equals. And the fact that it's negative, you can't have a negative 0. So when we multiply both sides by negative to create that to be positive, it's just negative times 0 is still 0. And so we get, this time, we get the probability of A and B is 0. Okay, and then moving right along here. Are A and B mutually exclusive? So mutually exclusive means that A and B, mutually exclusive mean they don't overlap. If they overlap, the probability of A and B would be something. When they don't overlap, the probability of A and B is 0 because they don't overlap. And if they don't overlap, they're called mutually exclusive. So this is events A and B they are mutually exclusive, right? And why are they mutually exclusive? Well, because the probability of A and B equals what? Equals 0. Okay, and then our last question. This is a nice quick one. It says, are A and B independent? So you can answer this question. How did we do this last time? Well, the way we did it was we said, okay, I'm going to compare probability of A times the probability of B. And if that equals the probability of A and B, if that equals, then they are independent. If that does not equal, then they're not independent. So maybe I'll put that over here. If equals, then if they're equal, then they are independent. Okay, if they're not equal, then they are not independent. Okay, let's see what happens. What is the probability of A and B? Well, we figured that out back here is 0. And what's the probability of A? Probability of A, once again, is 0.2, and the probability of B is 0.7. So we put 0.2 in here times 0.7. That sounds familiar to the last time. So this is 0.14. But even though the left side is different, 0.14 still does not equal 0. So this is still going to be the events A and B are not independent. Why? Because the probability of A and B does not equal the probability of A times the probability of B. And remember where we got this from. Remember where we got that from. We got that from going to our formula sheet right here. And it turns out, there it is right there, right? If the probability of A and B is equal to the probability of A times B, if they're equal, then they must be independent events. But if they're not equal, as we have right here in this blue, they're not equal, then they're not independent events. And that's probably the easiest way to do that. Okay, I hope that helped. And this formula sheet will be given to you. You could take it right here, right now. I'll also have it in Canvas under File, and I might be able to put it under Module 2. Maybe I'll put it in 2 locations. Okay, take care. I hope that helped, and have a good one. Bye.